welcome to Arlene Chevalier's Typewriter Alphabet Botany Flashcards curriculum. Today we are going to study stems. Stems form the structure of plants and are responsible for transporting water and nutrients. In this lesson, we'll look at various stems and compare their structure, vascular systems, and defense mechanisms. So you are going to need a few materials today. Of course, you'll want your journal and your pens and those sorts of things. You'll also want to have the typewriter alphabet, the DK Ultimate Visual Dictionary, and the DK Smithsonian Flora book. All right, so go ahead and get out your journal and I will read our definition for today for you. Stem, part of the plant that provides structure and transports water, nutrients, and sugars up to the leaves and down to the roots. May also perform photosynthesis and store nutrients. Okay, so we're going to ask a few questions and do some investigation. The Ultimate Visual Dictionary says that stems grow above ground, but is that always true? Where else can stems grow? So last time when we were looking at roots, we thought about bulbs, and we know that there are contractile roots on bulbs so that they're not always there. So if you have a bulb and you plant it in the ground, what are you actually planting? You must be planting something other than the roots, right? Turns out that you are. We'll look at that more in more stems lesson, but stems can definitely be underground. So there are lots of different kinds of stems that do that. Bulbs do that. Rhizomes do that. So if you've ever had ginger or turmeric root, those aren't actually roots. Those are stems. They're called roots because they're underground, and people think if it's underground, it must be a root. But that is not always true. It's a little bit tricky. This beautiful picture right here is a great example of another place that stems grow, which is not above ground. So stems can grow in the air, they can grow in the water, they can grow underground. They're pretty versatile. Stems are, I think, the most steadfast part of the plant. You can always find the stem. You may not always be able to find anything else, but I feel like you can always find the stem of a plant. There are so many types of stems. Vines, tree trunks, dainty petioles, herbaceous and woody, and even the Christmas cactus, which doesn't actually have any leaves. It's just pure stem all the way up. What are the advantages of each? How can each type use their stems to ensure survival of itself and its species? So diversity is always a really good thing. So you have lots of different types of plants that are doing lots of different things, and that makes the entire ecosystem more resilient because it has all these different types of stems. But even within each species, their stems are doing something really special. So usually with the tender stems, what will happen is the life cycle of the plant is built around the fact that those are tender stems, right? So they're going to be damaged. It's easy for it's easy for animals to eat them. And they're designed to come back. And sometimes even within the same season. So if a stem gets cut down, then it can just regrow new stems. And that's an easier process for that plant. And it's used to doing that on an ongoing basis. So if you have a tree and the trunks of the tree, you've probably seen a large tree get cut down and then it has a bunch of new little shoots coming off of it. But it's a lot more damaging to that plant, right? So it looks really different when you cut a tree trunk down and then it tries to regrow because it can't grow from where it was growing because that's all dead plant material all in there. So it's only growing from where there's actually still living plant material, which makes it look really weird. But with those herbaceous stems, the living material is everywhere at the base, so it can just send up new stems and they look like perfect and whole whenever they come up. The woody stems, how are they ensuring that they survive? So since it's really a lot harder for them to recover, they are protecting themselves with bark and the way that they are growing in the layers that they do, like it forms this really protective mass. So like even if things go into them and start eating the inside, the tree itself is still alive because it can withstand that kind of damage. I don't even know how damaging it is to the actual plant, but all of its vascular system is around that. So in the same way that the herbaceous stems are protected and that they can just replicate themselves, the tree is protecting itself and that it can withstand lots of internal things coming into the trunk, but still survive because of the way that the structure is on the outside. Third and final question and investigate topic is to look up pictures of maple sap being harvested to create maple syrup, one of my favorite things to eat. What is sap? We're going to talk about this more when we do the transportation of fluids. Where is the sap coming from and where is it going? Look back at your drawings of stems to see what the taps are boring into. So if you look at the structure of the stem, what is it that it's the same thing that animals want to eat. So if you see like aphids all over roses, they really love roses. They are drilling into that plant because they want to eat something. It's the same reason we humans drill into maple trees, because there's something delicious in there that we want to eat. What is it? What would be delicious? And what are plants making when they photosynthesize? So where is that delicious stuff coming from? And why? How is it getting transported through the tree? Finish your investigation with some pancakes and maple syrup, or something else delicious with maple syrup. Did you know that maple syrup is a superfood? Why would it be a superfood? So again, that all goes back to how that sap is created, what it is, what its purpose is within the plant, and then why do we want that? It's the same reason that we want to eat any of the vegetables and fruits. Like, we are looking for the same things that the plant is looking for. Like, what is that nutrition and where is that nutrition getting created, and why is it, the sap is running, right? So why is it running through there? So hopefully you can look at some really great pictures and then think about all that, mark it in your journal so that you can come back when we're doing the transportations of fluids lesson. So in your journal, there are a few things that we have listed. You can find a diagram of a stem, copy it into your journal and label it. Add your thoughts from the questions above and make up questions of your own. So along with that question that you just did, I assume that you'd already done this, so some of you might have already done a stem drawing if you did the monocot and eudicot lessons. If you haven't, just draw a stem diagram now. This page is actually super interesting in the visual dictionary. It has a lot of different stem types, and then it has this picture, which is a great little 3D drawing of stems. So those are all excellent. Pick one, pick the one that you think would be most useful, and just relax and do your drawing. Sort the cards into herbaceous and woody stems and make a list in your journal. So you may not know which are which, but some are obvious and you'll learn about the other ones as we go along. It's okay if you can't. Even when I was doing the sorting video for the very first lesson, the introduction to botany lesson, there are especially the yew, because I haven't ever grown Ulster Mary. Most of the other ones I have grown, but that one I was always like, no, I don't know, because I haven't seen that plant over years and know what it does. I don't know the growth patterns of that one. So as I was sorting the cards, that one was the one that was the most mysterious to me. So if you don't know them, that's totally fine. You will get to know plants. It takes a long time to get to know plants well. So just list the ones that you know and then be open to finding out information and discovering those things as you go along. Last one is people aren't the only creatures who want to tap into the sweet liquids running through plants. Draw and collect pictures of how stems protect themselves. So later on, we will study more about protection. But for now, this Flora book in the STEM section has some really great examples of how stems protect themselves. So these are, I'm going to just show you in case you didn't see them in the other video. This is a monocot and this is a eudicote stem sections. This one's really interesting. Sorry, I'm just going to show you some things. This is leafless stem, so like the Christmas cactus, like I said, is leafless. This we'll get into a little bit more later, but here are some really great stem defenses. If people ever tell you that every rose has its thorn, again, strawberries aren't berries, roses don't have thorns. These are all these crazy things that everyone just says, and they're part of the popular culture and the way that we speak about things, but technically these things are totally inaccurate. So do a little more research and dig in there and learn what's really going on in the world of plants. So enjoy your investigations this week with stems, and we'll see you next time. Bye, guys.